This is going to be a quick look inside video of this Velodyne ULD12 controller, which appears to be a subwoofer. I noticed this in the garbage area of my little development here, and I thought obviously not something I have any use for, probably no one has any use for, but there's something about it that intrigued me and I wanted to have a look inside. So we'll notice, what controls do we have on the front? We've got out, in, that's sticky, but it's all right. We've got a pot for subwoofer level. Okay, so it looks like it's a subwoofer controller. It's got, as it says, let's see what it's got on the back. It's got an output to the sub. It's got a preamp input and output, so there's got to be some filtering on that. And then it's got a speaker level input and output as well. Very common on especially older subwoofers, and if we look at this, the date is 2689. So it's from 1989. We've got a serial number, we've got San Jose, California. Okay, so what's interesting about this? There's no power connection, right? So it could all be passive, but when we flip over, we've got an LED for subwoofer. So I think it's got to have power coming in from the subwoofer input, which they could obviously put, 6 volts on that or 12 volts on that easily enough. Just need a capacitor to block it. But what's interesting about this is that means that this is probably active, and it's pretty light. So let's have a look inside. If it's an active crossover, what would we expect to see? Probably some op amps. It's 89 though, so we'll have to see what's in there. It does look suspiciously like someone else has looked inside this. If you look at the screw heads and the scratching, well, it could be from something else, but I don't know. We'll see. I don't know that I'm going to keep this. This may just go directly out where it was once I'm done. But something like this has a nice aluminum case, which you could use. You've got, pot, something that you could replace with a power switch, and, you could do quite a bit with this case if you wanted to. Oh, that's terrible noise. Sorry about that. So what have we got? Well, we've got presumably an op amp. I'll have to look that up. We've got a big pile of capacitors, 47 microfarad capacitors, all glued down. We have, that looks like it might have burned. Look, this resistor is gone. Bang. Filtering capacitors. I wonder what these are doing. Let's get this board out. Okay, there, we got it out. Now we can see the heat damage here where that resistor has cooked. There's our switch. What's this coming from? Okay, so here are, let's start with the speaker ins. So we'll just put this around so we can see what's what here. So these are in from the amp. So this is right channel and left. So right channel in and out. So let's follow what happens here. So I've spent quite a lot of time, well, according to the camera, about 20 minutes or so, trying to figure out how this circuit works. And while I haven't figured it all out, I haven't attempted to make a schematic or anything. I think I have a reasonable idea of how it works. The signal comes in from, the signal comes in via the speaker terminals, these capacitors, which are two banks, one for each channel, form a high-pass filter. They are 47 microfarad at 50 volts, and there's 5 on each of them, so approximately 250 microfarad aside. We could calculate what the frequency of that is, and I might later. Okay, so that's how that works, and the switch does appear to switch this capacitor bank in and out, essentially by shorting across the bank when the subwoofer's out of the circuit. So it shorts the capacitor bank out. There's no it's not filtering through the capacitor, so that's fine. Okay. On the other side here, we have an active crossover built over this, based on this 4-channel op amp. It's got what looks like a voltage divider with these two blown resistors and these two here, and these, I'm not entirely sure what this component are. I think they're capacitors, but the J, maybe they're inductors. But yeah, I'm not sure what those are. Anyway, it's coming through that, and these are being used to generate a low voltage signal to go into the op amp, and then the rest of this is generating the power supply for the op amp off this coming in. So that's where we see some of these capacitors around. These capacitors around are controlling the power supply for this op amp. Is probably 12 volts, and most of the components you see here create the filter that the 4-channel op amp here is creating. This transistor is switching this off, I think, when it's out of circuit, and the switch is switching it out of circuit as well. So you can see the tracks coming over here, and it's switching the positive side of both of these, which makes sense. I want to figure out what that component is, and I'm also very curious to test these capacitors, although I'm not sure I can test the whole bunch. In terms of what might be interesting in salvaging here, these capacitors, if they're good, would be fun to have. I don't think there's much else here that's of interest. Signal diodes and resistors and small capacitors aren't. I don't know what the transistor is. H945. But yeah, and I want to figure out what those are. So let me get out a component tester. I'm heating up the soldering iron in the background here. And let me get some stuff, and then we'll have a look. There's the capacitor. Leads are unfortunately very short. It's good. Oh, we will salvage those. So I was correct at the first. These are 0.22, well, as you saw, 0.224 nanofarad capacitors. I don't know what the J on there is and all that, but yes, these are capacitors as well. All right. Well, that is my all I really have to say. This is what I decided to save from it. Save the knob, because that's a standard base. I pulled out the op amp just to play with. I may have destroyed it by overheating it, getting it out, but we'll see. And I saved the Mylar, and these which I wouldn't use in anything good, but are useful to play with. Anyway, thanks for watching.